So Selden is a open source machine learning platform. And I'll be talking to you today about open source machine learning, some of the things that I've experienced taking a SaaS predictive API open source, and some of the things that have changed and evolved over the course of the last year. It's been a significant year for machine learning as a whole, and certainly open source has played a huge part in that. So first I'll take you back to August 2014. We're sitting in a hot, sweaty boardroom in London. We'd been building a SaaS predictive API, a content recommender, for the past 3 years. We're VC-backed. We're pushing hundreds of millions of recommendations through this service. And we were faced with a pretty difficult decision that day, whether to effectively exit the company, sort of accept a kind of acqui-hire type of offer, or to basically do something different. I don't want to get stuck in the weeds too much with all that, but ultimately through many discussions that year, I effectively had kind of a front row seat on the strategic direction of some of the world's largest organizations. And a common pattern emerged, and they were all putting machine learning and data science at the very top of their agenda for investment over the next few years. So it's really that sort of inspired me to take this company in another direction. So I was able to convince some investors to effectively back a management buyout. So I basically bought the company back, and after investing significant amount of time and the team effectively putting a good couple of million of R&D into that business, we spent our time. We decided that it made sense to do the thing which would be the most disruptive and make the most impact for businesses like the ones that we've been speaking to over the last few years. So here we are on Brighton Beach a couple of months later, sort of untethered from our previous roles, slightly smaller team, and we were plotting what we could do with Selden, and we were convinced that an open source solution would really give engineers and developers the tools that they need to build out solutions which are more, which enable companies to have more control over solving the problems that matter most for their business. So, sort of quick recap and where we come from. So we were a content recommendation engine, and we did some stuff with social data. We realized that data scientists were in short supply, and organizations want more control over their data science solutions. And also, predictive APIs in the cloud are fantastically valuable, but in many occasions, businesses want to bring the solution either on-premise or as part of their own dedicated cloud. So we created Selden. So Selden is, as I mentioned, an open source machine learning platform. We started as a recommendation engine, but we also wanted to broaden that to deliver more predictive use cases as well. So we built a microservices API, which I'll talk about more later. And it's very important that it's platform agnostic with no vendor lock-in. And obviously it's important that it can be deployed on-premise or in the cloud. A big change this year, we about coming up to 2 months ago joined Barclays FinTech Accelerator, which basically is a kind of partnership between the world's largest tech accelerator, Techstars, that started in Boulder and has many different programs running around the world, and Barclays, obviously one of the biggest banks in the world, to basically drive innovation through working with startups that are doing innovative things. And what we've seen through engaging with Barclays is that there's just enormous number of opportunities for companies that know something about data and machine learning to make a massive impact across the bank. not just in the kind of front office where you get all the investment in quant guys and sort of people at the very front on the sort of sharp edge of actually generating revenue. It's in all the kind of back office and all the kind of things like fraud detection, credit scoring, and even HR. There's just massive, massive opportunities. So what we're trying to do is build out some proof of concepts, and it's important that we focus. We're a small team, we're actually, I'll talk about this more later, but we're actually building out a machine intelligence ecosystem with Seldom. So another reason, 2016 obviously is a breakout year for machine intelligence, and some of the themes and interconnected market forces at work which have made that happen, which are kind of some of the reasons that I had for making this big plunge towards open source. Sort of on the economic side, we have massively reduced compute costs, both on CPU and GPU. I think I heard a fact, it's something like 250 billion transistors were produced in 2014, which is like more transistors produced per second than there are stars in the Milky Way. And startups disrupting the incumbents, especially in the financial services, unbundling banks and creating more innovative applications. Data privacy and compliance are both really massively important to a lot of organizations. Consumers now expect smarter applications, and the workforce is becoming increasingly automated. Some 58% of jobs activities will be or can be automated. I think it's something like 47% of jobs in total will be. Data scientists and decision makers want more control. There's this increasing commoditization of machine learning technologies. Obviously, we wanted to be a part of that rather than sort of fighting against it and getting disrupted. And there's this sort of 2 billion smartphones now and 13 billion connected devices. The whole Internet of Things space is just growing massively, which is leading to this exponential growth in data, which we can all use to create smarter and more intelligent applications. But if you look at this year, obviously we've touched upon this a couple of times already today, but there's the most incredible events are happening with coming out of DeepMind and AlphaGo. So this board game is very special. Obviously, there are so many moves. I think I read recently there's more potential board positions than there are atoms in the universe, which is pretty mind-blowing. And you can't solve this by brute force alone. I think this is sort of kind of like a brute force sort of I suppose tree diagram, which is looking at all the different possible paths you can take from that the current board position. And actually, DeepMind use a lot of open source technologies internally. They're massive contributors to Torch, for example. And it's unlikely they would have actually been able to achieve this massive milestone achievement if it wasn't for open technologies. So, going back to what we're doing, so we're wanting to build out this machine intelligence pipeline. So what is that? So first of all, you have to ingest the data. You need to sort of find a data source which you are able to actually pull into a system. And when you do that, quite often that data is not in a format which is fit for that particular purpose. So often you have to go through a stage of cleaning and feature extracting, and that data is used to train, build models. And those models can be industry models or models that you build in-house. Those are used to deliver predictions, both recommendations or sort of other kind of classifications or regression scores. And those, you're doing it for a reason. You're doing it to monitor, to impact some business KPI. So it's very important that you're monitoring those KPIs. What is the impact on churn? What is the impact on CTR? And that gets fed back into this system as a sort of virtuous sort of feedback loop, which is enabling the system to learn and improve over time. So that's what we're trying to build. And how do you go about sort of building and adding machine intelligence to your company? So on sort of a 25,000 feet level, you've got a few different choices. So you can build it in-house. And building it in-house, you have total control, obviously. There's basically infinite models to evaluate and build because you and your engineers can just build anything out of any of the open source or kind of totally custom tools that are available. It can take a hell of a lot of time, and you need a lot of data scientists to achieve the same type of thing. And obviously, as you mentioned, they're in short supply. So it's expensive. This is why people build predictive APIs. So, predictive API makes it a lot easier for you to build out these sort of more intelligent predictive applications because they're abstracting all of that complexity of building it in-house, and they do a great job at it. But it comes at a cost. One of the costs there is actually control. Because a lot of the kind of SaaS-based APIs, they shield some of the more nuanced things that you would want to do as an engineer or a data scientist. But they save a lot of time, and you need less engineers. So there's the sort of best of both worlds that we're aiming to deliver with an open source predictive platform. This enables you to have more total control because you're basing your technology on a fully open stack. It contains models that you have built or we have built. We're actually looking to build out industry models which are focused on solving specific use cases, so you're not all trying to reinvent the wheel. And although this can take a little bit longer, depending on the size of job, all this is sort of relative to sort of real world situations, but ultimately, in general terms, it can take a little bit longer. You use less data scientists than if you were to build this in-house directly, and it should cost you a lot less. So this is sort of an analogy that I've used sometimes to sort of try and simplify the control that people want, data scientists want. So if you look at this DJ controller, I'm not sure how many DJs in the room here, but to try and simplify it, I talk about the predictive models effectively being different channels that you can sort of select, which of these are being used in production at this time. And with the actual sort of bass, mid-range, and treble are the hyperparameters. So the DJ is there actually sort of fine-tuning that according to the audience and trying to sort of optimize the experience for that moment in time. But there are many, many different sort of segments of customers, and there are many different possible combinations that you would want to try at any given time. So effectively what we're trying to do is enable all the data scientists to effectively DJ in every room at the same time at a very big party. This optimization layer is a really fundamental part of what we're building with Selden, and this is actually a very, very big sort of field of machine learning and data science. Optimizing the parameters which are sort of an input into the model rather than the actual model itself. So we released our open source in February 2015 after a few months, for about 6 months. And here are a few things that we learned through that process. First of all, we were a SaaS platform. And as a SaaS platform, you don't have this requirement of having to kind of take your stack and sort of put it on a client system. It's something which your engineering team have a lot of in-house skills that they develop for deploying, and they're kind of happy to work with some sort of imperfect ways of doing things versus what you need to do to actually put something out in the real world and have people use it. Because if people aren't able to actually get something up and running quickly, then they'll just get bored and move on. So we focused a hell of a lot of time on that. And actually, even just giving someone a pile of source code is not really ideal. So one of the things that we did is create these virtual machines that have basically all of the different components within Selden pre-wired and sort of ready to spin up on a laptop or a server, so you can just get started and have an API ready to receive data on your laptop, and then you can sort of work with that. that virtual machine can work on any environment, but we also have cloud platforms like AWS, where a lot of you familiar with things like AMIs that you could use to deploy the same technologies there, and Docker containers, which we have also created, and that's actually a technology that's become a lot more mature over the last year. We found it was quite brittle when we first started looking at it, but now it has some fantastic orchestration technologies built in that really enable you to sort of fire up a complex infrastructure stack. Really important to document everything properly, and actually in the past I'm almost ashamed of the fact we used to use PDFs ourselves for sort of sharing private documentation with clients on our API and how to get everything ready. We moved that to GitHub, and I would recommend anyone actually using GitHub for documentation, whether or not you are actually open source, because actually what we found is that some of the first pieces of community engagement that we saw were actually people sort of fixing and making comments on our documentation. Choosing an open source license is really important process for us, and it's one of those kind of situations. I'm not sure if you get the analogy of you can't put the toothpaste back in the tube, with those kinds of decisions. It's something we thought long and hard about, and basically we ended up choosing Apache 2, and the reason for that is that businesses, as much as they love sort of using open source software, they don't necessarily want to make all of their software open source. And there are some, the alternative there is the most common one is GPL, and with GPL, and there's a Affero GPL, they have this kind of copyleft thing built into them, which can be circumnavigated, but can scare businesses. So we wanted to make technology which can be widely used with confidence by organizations. So one of the interesting things we found, though, is that we were a SaaS platform, a SaaS business, and when we went open source, we actually didn't lose any SaaS customers. So they were quite happy for us to continue to deliver the service, and they were paying a reasonable amount for that. They didn't just download the source code and decide to go it themselves. And we also found that the open source was a really great driver of SaaS business as well. We previously would have to work really hard to sort of get on the radar of companies and go through a process of a standard sort of enterprise sales process. And now quite often when we speak to a company, they will already have some engineers who've maybe downloaded our virtual machine, but then but they have some maybe long-term plan to bring it in-house. But in the meantime, we can host it and deliver it as a SaaS product. I have to say that SaaS is still in a very early stage still, even though it has been used in production very heavily. We have plans to make it much more turnkey. So it will be effectively like a lot of the other SaaS services you see online, where you just sort of turn up and put in a credit card and are up and running in a few minutes. I think I've just covered that point, actually. The sales cycle generally, it did grow, and now it's actually shrunk a little bit. But the main point there is that open source is basically the main driver of all of our sales at the moment, to the point where we don't really do any sort of conscious outbound sales. So finally, super important to nurture a community within an open source business. We've sort of changed how we communicate, since going open source, because it's like we're talking more at a sort of broadcast level than sort of on an individual basis. So we're sort of using the kind of common tools you would see there. So things like our users group and newsletters, and we've done things like webinars, and we want to do much more of that, and give members of the community an opportunity to sort of benefit from some of the reach that we can give them as well. So anyway, that 9 months later from us open sourcing, I think this is sort of pre my last PAPIs talk in August last year. Was it August, September? We were all talking about open source being, Selden and our friends at Predictive.io, and not really any sort of big players. But then, it all just sort of came at once of every single big company, most notably Google and IBM and Microsoft, and all sort of releasing major open source technology platforms, or open sourcing their machine learning technologies, which is massive news. I mean, it goes with the trend of what I was experiencing and what a lot of us were experiencing with open source technologies, or the commoditization of machine learning. But this was a massive event which is no doubt accelerating the progress of the field of machine learning as a whole, and is great news for everyone in this room, I believe, and including me, including anyone doing building out an open source machine learning platform. So just give a couple of I'll talk more about that in a minute. The community. Just a few sort of anecdotal things we've seen in terms of like the evolution of how people engage with an open source project. So the first thing we saw was people sort of fixing documentation, which was nice. Some of it was typos, some of it was sort of things that were not working. Then more recently we've seen actually like a big milestone of people actually helping each other. I was so happy one day when I logged in on a Sunday evening and saw that one person had actually answered a problem, a technical question from another community member that I didn't know who either of them were, and that was just a massive, very happy moment for me. And then sort of finally fixing bugs, actually going in there and submitting a pull request. I have to say this is something which, if you're building out an enterprise open source, there's slightly less, it takes slightly longer, I believe, to actually get to the point of having people like do pull requests, because a lot of the people who are using your product are working within organizations where, due to sort of internal policies, it's slightly trickier for them to sort of do that pull request. But we are engaging with the community. We have currently about 112 forks, I believe, on GitHub, and we are encouraging people to contribute back. So in terms of what you can build, I mentioned we came from recommendation backgrounds, so just sort of a quick run through of the sort of types of algorithms that we had in play. So we had user clusters, so in each of these different algorithms obviously works better in different scenarios. So user clusters work great in a sort of high churn environment, sort of like a media website for breaking news. Then you have here tag affinities, which are sort of connecting tags and events based upon sort of associations and sort of how closely they are related ultimately. Latent factors, good for sort of a low churn service. So things like Netflix, where you maybe want to watch Breaking Bad like a year later. It's not something which kind of goes out of date too quickly. Item activity correlation, your kind of classic people who bought this, bought that, sort of Amazon type of model. So topic models, actually very good for the sort of unlocking the long tail. So people like Etsy, for example, use topic models a lot to sort of help to align or to recommend things that are connected with people's sort of niche interests. Association rules, so sort of basket analysis, understanding based upon that there's these sort of set of actions, what you might want to show someone next. And then content similarity. So all the above ones are kind of related to activity-based recommendations, and content similarity, is really just looking at the metadata associated with that content and using that to make connections. So there's a lot of different algorithms there, and not all of them will work best on their own. If you look at any Kaggle competition, or even the AlphaGo thing, it wasn't just one algorithm which sort of saved the day. Ensembles are a combination of different algorithms which are combined to based upon Here we're talking about like the relevance, popularity, diversity, for example. And then actually you're testing those combinations in a sort of real-world environment. So you're looking at what impact it has on those KPIs. And that effectively, you can think of it like an A/B test or multivariate test. And it's very important to have an environment where you can quickly test various different combinations of models and algorithms, basically. And that's one of the things which we built with Selden. So selecting the best model to sort of extend on this point, to sort of visualize it. So you have a sort of a best algorithm and a sort of a test algorithm. And think of it sort of like an A/B test, and one of them is performing better than the other at that time. What if like the test algorithm suddenly starts to perform best? You should really sort of take that to promote that to the best algorithm at that time. But then one of the things we're trying to do next with our sort of optimization is to have many different strategies kicking off at the same time, and for the best one of these to actually be promoted. So this kind of technique is something which we were working a lot, or we're using a lot within the sort of recommendation space, but we wanted to extend that to deliver more sort of general purpose predictions. So in this environment, we're streaming the events in real time, and these events will not necessarily be the same type of events as a recommendation, which I'll talk more about in a sec. They are supervised learning pipelines, which can handle sort of classifications, so kind of binary classification, used in things like fraud detection, for example, and sort of multi-class in things like triaging support requests, and then sort of predicting a continuous value. In order to deliver that, we didn't just sort of try and rebuild all of this stuff from scratch. We wanted to utilize the best technologies that are available at that time. So we used, for example, this selection of different open source libraries like Vopal Webbit, XGBoost, et cetera, et cetera. Actually, Keras is a Python-based deep learning library, which actually has inadvertently, it's basically gone on to support TensorFlow. So the example I gave earlier, you now technically can put a TensorFlow model into production with Selden, but we're going to go much further than that over the course of the next year and actually actively support it. So Selden microservices, quick run through of how they kind of all wires together. So you have Selden Server, which is the main project that we have within Selden, and your app or service. So this is a REST API. So on the recommendations, you have the endpoints for a user, an item, and an action. And that's posting into Selden Server. And you're getting back recommendations. For the predictive side, you have, you're posting in events. And events can be basically a free-form blob of data, of structured data. And you're getting the predictions back. So when we actually introduce this microservice, we have this internal API which has connected these different libraries. So that's actually getting a predict from Vopal Webbit, from XGBoost. So it's acting like a kind of a common interface to these different libraries. And you can actually connect not just like open source technologies, but also proprietary APIs as well. So we're doing some work with IBM Watson, for example, to integrate some of their natural language processing capabilities. So go to market. So we are a very sort of general purpose platform that could be used to solve many different problems. And this is sort of some of the thinking that's come out over the last month or last couple of months. And when you go to market, you've got to think whether you are like a kind of more of a horizontal play, kind of a platform, or are you kind of more of a verticalized, sort of focused product? And are you more of a product, or are you sort of more of a kind of consulting type of business? And I'd say that we were actually sort of down here. So we were kind of the mule just after post open source. So we had a horizontal platform delivering a lot of services on top of that. And this is kind of where, you know, where you should be sort of heading, where the sort of, the sort of playbook for most technology startups says that, you know, you should be sitting in the zone where you have a product which solves a very specific problem. But actually getting straight there for us, you know, kind of crossing this X here, you know, doesn't seem to make sense for us. So actually what we're looking to do is first productize our platform, make it much easier for you guys to sort of work with it, and also then pick off a few very specific use cases like we're doing in financial services, where, you know, we are you know, delivering more sort of focused solution which captures more of the value or delivers more of the value. And hopefully, you know, we'll actually spawn many unicorns in doing that, as there'll be lots of other people, you know, building fantastic applications off the top of this platform. So we're building out a fully integrated open source ecosystem with microservices APIs, open source libraries, both and closed APIs that you can connect as well, or your own proprietary models. And one thing I haven't spoken about just now is about global models. So, you know, the way things kind of like generally work as an open source platform or as a kind of consulting company is you deliver a service and the model sort of sits within that service delivery. But if you were, say, Google delivering a sort of spam detection engine to Gmail, you would have that sort of tightly baked into that sort of cloud-based, you know, SaaS-based product. So we're looking at ways which are benefiting sort of all of our users as a whole that enable you to basically share, you know, some of the insights that you're delivering from that model. And that's all I can really sort of say at this time, but I'm very interested to talk to people about you know, this plan and sort of get feedback. It's obviously one of those things which gets mixed response based upon the industry and the company, I suppose. But I'm here to get feedback. So I won't go into too much detail on the infrastructure here. This is our V1 container-based infrastructure. We're using a real-time layer, storage layer, offline layer, and stats layer. And then Seldon 2.0 that we're building right now, just to whiz through. Flexible design using Kafka as a hub, data pushed into DBs and processing units as needed. We're streaming algorithms via Flink or Spark, dependent on latency requirements. Batch algorithms by Spark or Flink. And using things like Luigi pipelines for sort of batch processes, something that came out of Spotify. Docker Swarm for deployment. And sort of single machine for agile development. So this is something we're building right now. You know, we have things like TensorFlow in there. We have things like Flink. You know, it's a number of different data stores from you know, graph databases to in-memory databases, HDFS, Hadoop, etc. So you know, this is kind of where we're heading, and obviously it's an area that I'd love to get again feedback. So a few just main key takeaways before I sort of finish up. So this year is the breakout year for open source machine intelligence. Data scientists, you know, and decision makers, you guys as well want more control. And you know, open source really helps you to focus on that last 10% of the problem rather than sort of reinventing the wheel and trying to build everything else from scratch. We're also hiring, and on that note, I'll just say thank you.